All right, we'll go ahead and get started. So hi again, everyone. Again, my name is Alex. I am a account manager here at NetBeez. We appreciate you guys taking some time out of your busy day to spend a little bit with us, and hope that you find this time valuable. One of my responsibilities with NetBeez is providing assistance and onboarding for healthcare organizations that are interested in evaluating proactive networking techniques for their IT teams. So again, we're going to be doing some question and answer at the end of the webinar today. So if at any point in time you've got a question, you can go ahead and ask away down at the bottom, and we'll get to it when we can, okay? So let's get started. Today's webinar is going to be mainly focusing on mission-critical environments such as network infrastructure and IT systems of healthcare organizations. The team here at NetBeez really has some extensive experience in working with various healthcare organizations throughout the country, but these, what we're going to go over with today really can be affected by any vertical, any organization, but we're going to primarily focus on healthcare. Also with me today, having co-host, is the one and only Stefan Interview. He is one of our co-founders and our CEO. And this topic is pretty close to his heart, as in a prior life he worked as a senior network engineer at a large healthcare organization here in Pittsburgh, and has a thing or two to say about his experiences within that organization. The goal of today's session is to review monitoring concepts and techniques and strategies that will enable network engineers, managers, and architects to really achieve the maximum reliability and uptime of network infrastructure that is responsible for assuring fast and accurate patient care. So first, let me review a couple of basic network monitoring concepts. We're going to be looking at time to detection as well as time to resolution. We'll then see how these two important metrics are factored into network availability and uptime, and we'll also learn how to calculate these key performance indicators. In the second part of today's webinar, we're going to see what active distributed network monitoring is and how it differentiates from SNMP or passive monitoring. I'll show you how active monitoring can be effective in proactively detecting network and application incidents, and how distributed network monitoring is used to perform fault isolation of such problems in complex and highly distributed enterprise networks. And lastly, Stefano and I will review a use case for a healthcare system that has decided to implement proactive network monitoring. And again, Stefano will share his firsthand experience as a senior network engineer. All right, so let's get started. So when thinking of network monitoring, you have to think about its end goal, which really is reducing time between when a problem arises and when it's resolved. So network and application outages that cause partial or complete service interruptions are usually detrimental to the end user experience and the business overall. And so our goal here at NetBeez is really to minimize it, as well as our job as network engineers is to minimize that effect and that impact on the business. So simply stated, time to detection is the time that it takes for a network or application incident to be detected and notified to IT. This can be highly decreased via active monitoring, and we'll see how the next slides will show you how. The time to resolution is the time that it takes for IT to find the root cause and restore the service to its original state. Now, there's many things that factor into the length of this period of time, such as the integration level between network monitoring, network management tools, the efficiency of incident escalation procedures, team expertise, how well the architecture and design documents are maintained. And of course, this is just an incomplete list, as there could be a host of other variables that weigh in on this type of information. So this leads us to the concept of mission-critical systems and network availability. And the goal of offering a mission-critical service like in healthcare environments is to really minimize the downtime and assure a well-performing and resilient service. Wikipedia says that a mission-critical system is a system that is essential to the survival of a business or organization. When a mission-critical system fails or is interrupted, business operations are significantly impacted. And I'm sure most of you have had had a circumstance within your career that you saw this to be very, very true. This is especially in the case of HIPAA networks, along the lines of healthcare, electronic medical records applications, heart monitor machines, and other systems within the environment that doctors and nurses rely upon every minute of the day to deliver patient care. So mission critical systems have very strict network availability requirements. For example, a 4.9 system can only be unavailable for 4 minutes and 32 seconds a month and 52 minutes and 56 seconds a year. Now, please be aware that even if this figure only accounts for unplanned downtime, which is a service interruption that was not previously scheduled for, such as a software upgrade or a network maintenance, it is still a very small number. Network monitoring can help with meeting these strict availability requirements. More so, proactive monitoring. There are two monitoring techniques that are employed by NetBeez that provide useful healthcare providers in meeting their availability goals. The first one is active network monitoring that facilitates quick detection of a network and application issues. And the second is distributed network monitoring. It is very helpful for fault isolation and quick troubleshooting network versus application issue types of problems. So let's cover active monitoring first. So active monitoring is performed by running real tests on the network to verify that the network and applications are available and well performing. The active tests measure end-to-end reachability, packet loss, jitter, bandwidth, and application response time. You Cisco engineers out there may find this technique similar to the IP SLA tests that are run by the routers and the switches. This method is very effective to quickly detect network and application problems because it tests the actual network routes and applications with real traffic instead of monitoring individual devices in a network or components of an application to infer network and application availability performance for the end users based on the overall status. Based on the frequency of network application tests, IT can also decide how soon a problem should be detected. For example, in this table, we see that if we run a ping test every 5 seconds and declare a remote network unreachable after 5 consecutive fails, we'll have detected a connectivity issue within 25 seconds. That is a very short detection time when compared to the 5-minute interval that most SNMP systems are configured to by default. To conclude, you should implement active monitoring against web and cloud applications to proactively detect network and application problems on large, complex enterprise network environments. Now let's take a look at distributed monitoring. Distributed network monitoring is a monitoring strategy that collects availability and performance data about a specific monitored object from multiple observation points, such as agents or sensors. The goal of this type of monitoring is to really determine the real status of the monitored object, also called a target, independently from the network conditions that may affect the measurement of one or more observation points. Take, for example, the case of when your SNMP server located at the data center can't connect to outside networks for some reason. The server would generate many false positives as it's not able to get responses from outside devices. With distributed network monitoring, this problem doesn't apply. Now, one of the main benefits of distributed network monitoring is that it makes it easier and quicker to find out if a problem is network or application related. So in other words, proving that it's not the network. The rule of thumb is very simple. If only one sensor has problems within an application, then it may be a local network problem where the sensor is installed or somewhere between the sensor and the application. If, on the other hand, all sensors are reporting problems with one application, then it's probably an issue with the application itself. Of course, one important requirement of this monitoring is that enough diversified and redundant sensors are deployed throughout the network as a whole so that they don't share one common point of failure. Without distributed network monitoring, this type of troubleshooting usually takes a lot more time, resources, and expertise than needed. So now let's put together all the pieces of the puzzle and see how we can improve network uptime with active and distributed network monitoring. At this point in time, Stefano is going to come in and we're going to ask him some questions here. Hey, Stefano.
Hey, Alex, and hi, everybody.
Hey, thanks for joining us today.
Good, good. Nice t-shirt, by the way.
Thanks, you too. So question for you.
Yeah.
Tell us a little bit about your past experience and what were you responsible for with your past job?
Yeah, so that's probably most of you know I was like a network engineer before working on NetBeez, and I was in the network design team. And as part of the network design team, we were responsible to design as well as implement enterprise networks. In this case, was for large hospitals, small data centers, or physician offices.
Awesome. And in this environment, I mean, what were some of the challenges that you faced? Some of the monitoring challenges specifically that you faced within the environment?
Yeah, so really like as you said in previous slide, detecting problems before the end users, and then troubleshooting problems without having like a bunch of like network engineers and application support and nurses in the process of troubleshooting and collecting data. When you get a call and you don't know what you're dealing with, you have to find out, is this a network problem? Is this an application problem? So that was almost weekly or monthly. And there were, conference bridges where everybody would join and everybody would try to collect information about the problem. So that, of course, was really like, it takes a lot of time to find information to troubleshoot and quickly address the problem. And it was not really because like the people where I used to work didn't know what they were doing. They were really like skilled people, but we didn't have the right tool in place, such as SNMP or NetFlow. On this were not appropriate to quickly detect connectivity issues or application performance degradation issues. On the other side, NetFlow is the same. They give you a good understanding of how your network is used, but it's not that it continuously check for you the status of an application or a service. So the local versus global type of troubleshooting was always happening, and it would happen with human resources in the end.
Gotcha. And we're not talking about a small infrastructure. We're talking about a multi-million dollar corporate enterprise network that this was happening on, correct?
Yeah, exactly. And yeah, I mean, the company I used to work with was pretty large, many remote locations. So in fact, the more the remote locations, the more the mission critical applications that you deliver on top of a network infrastructure, and the more you deal with these sort of problems on a weekly or maybe daily basis. So now, of course, networks are everywhere, cloud apps are everywhere. So this is getting always more kind of a universal problem. Yeah.
Wow. Okay. So can you kind of go back into your mind a little bit and pull out a specific time or circumstance when really the active and distributed monitoring would have helped save a bunch of time, energy, and frustration on your part?
Yeah, so I would say like troubleshooting. Another like use case that happened is like when there was a network change to be applied on the network. It was a routing policy change, and I remember that, of course, you do it at 2 a.m. in the morning to make sure that you cause the least disruption, right? If things go wrong, but even during the change, no matter what. So you apply the change at 2 a.m. and then you think everything looks good, right? No syntax error, the router switches are up. And then the next day, 8 a.m., that routing policy change didn't account for some routes to be redistributed, and those were, kind of data center routes. So as a result, the next day, people that try to log into their workstation, because of, this routing policy change, they couldn't log on to their workstation. So this is one of those type of problems that with SNMP or NetFlow you cannot detect. You only need a set of like active sensors that do that test continuously, so that when you push a configuration change, you can immediately check that remote sites, remote users next day will still be able to access their applications. So that was like one use case, but I mean, as you know, like then even with many other users, we had the same feedback that, you do routing policy changes, firewall configuration changes. You don't have a good way to validate that in an efficient way outside like having a bunch of SSH or telnet session from remote hosts, right?
Gotcha. Okay. Awesome. And so, I mean, on the next slide, we have kind of a not uncommon, right? This is a pretty common overview of an enterprise network. This particularly, we're talking about healthcare, but again, other industries, verticals, retail, hospitality, banking, things like that, really have similar looking infrastructures. So, speaking into this particular healthcare use case. With time to resolution and increasing network uptime, how could NetBeez help an organization like this just do better in general?
Yeah, so like in this case, I wish I had that when I was working, of course, a tool like that, active and distributed. Like in this case, we have, for example, let's take an healthcare system with two data center, primary and backup, even if now everybody uses kind of everything active, and then there is, but in any case, two data centers, 10 large hospital, and a certain number of remote physician offices. We have many customers like that. And generally, like the best way is like deploy a virtual agent at the data center, because most of data centers are wired and they have a bunch of hypervisor or VMs there. So deploying a virtual agent is the best way to go. Then in the case of the large hospital, we generally would recommend installing 1 gigabit Ethernet, which can be used not only to do the kind of web-based app or electronic medical records app monitoring, but also do the throughput testing for bandwidth. And then Wi-Fi agent, because Wi-Fi is very important in hospitals. Like there are a lot of areas like emergency rooms, operating rooms, or ICUs where a lot of equipment is wirelessly connected because of the nature of the business. So in that case, we would recommend, of course, install a gigabit agent along with many Wi-Fi agents in multiple strategic areas. And then for the remote physician offices, the best is like you can install a smaller hardware agent, a fast Ethernet, which again, even if nowadays all users connect with Gigi, still you don't need to push 1 gig of throughput for remote offices. Generally, a fast Ethernet throughput test alongside the cloud web-based app monitoring is just good enough. So in that case, you can deploy a hardware fast Ethernet agent along with a Wi-Fi agent as well. Because also physician offices oftentimes have tablets that they use to work with their kind of customers, which is patients. So yeah, generally like this is a typical configuration that we would recommend to healthcare systems with virtual agent at the data center, gig and Wi-Fi at the large hospital, and then smaller units at the remote physician offices.
Gotcha. Awesome. And then, so speaking to a little bit about how scalable, because I know there's a lot of healthcare organizations that grow rather quickly, and there's acquisitions that take place. How scalable is a solution like NetBeez to really be able to absorb and be utilized at those additional remote locations? Is the setup difficult? Is it complex?
It's pretty quick. I mean, the server is scalable. Of course, the server is the controller, the central unit that manages and collects the data from the sensors. And that's really scalable based on the number of units deployed in the network. And adding more units in the network is really plug and play without needing for specific configuration from the end user, which is the engineer that uses NetBeez. So it's fairly scalable, as you know, some people start with a smaller set of sensors and then they expand always more to include more remote offices into the monitoring.
Absolutely awesome. And this, I know we're specifically talking about healthcare today, but this is true for any industry that's out there as far as what NetBeez can do and what even distributed and active monitoring can do within those organizations, right?
Yeah, exactly. Nowadays, always more. I mean, I think healthcare has been always in the forefront, along with other industries. But it was one of the first industry adopting really IT technology for delivering patient care. And I was lucky to be part of that environment as a network engineer because you have a mission critical environment where uptime, reliability is very important. But again, this is something that nowadays in 2018 is common across retail, banking, even like companies from the mid-market from other industries nowadays.
Awesome. Okay. And so specifically speaking into ROI, right? Return on investment, for an organization, whether they be healthcare, hospitality, or banking, or retail, or even some of the larger technical, tech organizations that are around, what types of returns could the organizations expect to see by just investing in and looking into some sort of active or distributed monitoring solution?
Yeah, so there are two main, it's really twofold in terms of ROI. First of all is reduced network downtime. As you shown in the previous slide, I mean, no matter what, you have faster detection of problems, of performance issues, and faster resolution time of those performance issues. And that means less downtime with your customer-facing applications. In the case of healthcare, of course, we're talking about people's lives and patient care. But in other industries, I mean, if you cannot run transactions on your network, your customer, in case of retailers, will walk out of your store and go to a competitor. In the case of banking, you're not going to be able to process transactions and so on. Think about even manufacturing. If your machine that are IP connected cannot function, then you have to stop the production. And on the other side is, of course, decrease in operating costs. First of all, like in the case of troubleshooting, the time to resolution, without like automated distributed active monitoring, you would have to rely on people to collect that information, and they are less efficient than a computer in the end. So you spend more. Your staff spends more time into troubleshooting problems, and thus there is a reduction in productivity. While on the other side, if you implement such a tool, which is in the end a productivity tool for an IT team, you can do more with less. So your team will increase productivity, and perhaps if you're expanding your footprint, now you don't have to hire another engineer, but you can do work with whatever stuff you have right now.
Gotcha. Awesome. Good insight. So I appreciate it. Thanks for sharing a little bit about your past experiences, what you've gone through personally, some of that stuff. I know that will be valuable to some other folks that were in the same position that you were in. So at this point in time, I mean, we can go over to Q&A. Looks like we did have a couple questions come in. And let's see, the first one says that these are great use cases. How do they apply to other industries? And I think we went over that a little bit, but if you want to dig into, how some of these use cases might apply to some other industries.
Right, and in my examples, even in the slide, I didn't talk about HIPAA. I didn't talk about like the guest Wi-Fi that was in the previous slide. But I mean, right now, like, for example, Wi-Fi is another use case that is not only healthcare, but it's also, retail, for example. It's big on Wi-Fi, use of Wi-Fi. So really the use cases that we shared about troubleshooting a network versus application issue is actually something that we heard back from customers from other industries. For instance, we have the EI network, they're an MSP. They support the Carnegie libraries here in Western Pennsylvania. They have probably 70 plus Carnegie libraries. And of course, one app that is very important for their end users is the catalog, where users at the library go on the web-based catalog to search for books. And that's a web app that must be monitored. And you want to make sure that all the remote libraries can access that catalog in real time. And if not, you want to understand if it's a problem at the local library or is something with the catalog. Well, the EA network, for example, use a lot that level of troubleshooting local versus global to see if a problem with an app is network related or app related.
Awesome. Okay. The next question that we have here is, do you have any higher ed use cases? Have you tried deploying agents on campuses with many buildings?
Yeah, definitely. We have like, especially like technology companies, they have like many worldwide global offices all around the world, and they're one of the primary users of distributed network monitoring. Actually, it's an industry we had a lot of success with, as you know, Alex. And generally, like what they do, they install one wired and one Wi-Fi agent to monitor both networks, and as well as to understand if there is a performance issue with the Wi-Fi. Is it common with the wired agent or not? So is it only a Wi-Fi issue, or is it a problem with a maybe wide area network link? So yeah, totally. I mean, distributed network monitoring means your network is not comprised of only one building, but multiple buildings. You have a large wide area network, and that's where you need remote sensors at each of those locations to understand what's going on in your network without having to rely on the end user that call you and open a ticket when a problem happens.
Awesome, awesome. And I know for a fact that we do work well with educational institutions primarily. We've been seeing a lot of traction in that vertical lately. We've got another question here. Can you use the agents to monitor ISP performance, i.e. speed tests and latency? Can you speak into that a little bit?
Yeah, so cloud and web-based apps, they're not the only type of apps that you can do with distributed network monitoring. Another good value is like running speed tests, for example, to gather download and upload speed of all your remote locations. As everybody knows, probably when you have a problem with your SP, they either send out a technician. If you're a business user, if you're a home subscriber, they ask you to go to speedtest.net. That's something that is a good way to troubleshoot the download and upload speed and the performance of your internet connection. Problem with that is that you only run it after the fact when you have a problem. The beauty of having remote sensor out there is that they continuously, well, maybe periodically do it once an hour or twice a day. They run this type of measurement, so you have a baseline, you have a clear understanding of how good or bad your download and upload speed is, so that you can be better proactive, but better at troubleshooting problems that you have in the network. So bottom line, yes, you can use agents to monitor ASP performance. And in fact, not only like enterprise users use such a technology, which is NetBeez or whatever active distributed network monitoring they may have, but also ISP, the internet service provider themselves, are always more adopting this because they don't even themselves have that visibility from the end user or subscriber perspective. So yeah, it's a totally strong use case.
Awesome, awesome. All right. Well, I don't see any other questions. I think we're going to wrap it up for today. So for those of you that again took some time out of your day to spend with us, we appreciate it. Thank you so much. We hope to see you guys soon. If you do have any questions later on, you can feel free to reach out and contact us directly at sales@netbeez.net. And one of our account managers here will get with you. And if there's anything that we can do, man, we are always here, always willing, looking to grow, looking to do better, be better. So whatever you guys need. Again, thank you so much. We appreciate you all. Love you guys. You take care.